Okay, in this section of the video, I'm going to go over some basics on the engines and show you how to load that into an engine casing. So what you're looking at here is my laptop, and on my laptop I have a computer program called RockSims, and basically it's a simulation rocket assembly. You can use it to design rockets, you can model kits. In this case I modeled the Initiator. This is the kit that I'm showing in the video, which should be very close to yours, but the idea is as you're building the rocket, you actually take in dimensions of the individual components, you're weighing them, entering that data, and ultimately that's how you get your simulation results. And you tell the program to assume certain weather conditions, wind direction, gives them you tell it, how long your launch rod is, and then you select an engine, actually load an engine in the simulator, and it gives you all your stats. So for this this rocket, I'm using a real simulation from the rocket I built and I've been using in the video. That's this one here. So there's two engines that you're going to be using, and I sent you a spreadsheet that kind of summarized some results from the simulator. And basically we're going to be using two engines. One is called a CTI 57F5912A, and the other one is a 108G 57-12A. So to go over a little bit, this is the White Thunder engine, identical to what you received, and this is a 29-inch motor. The rocket is built, the motor tube is built to take 29mm diameter engines. And in this case, you can see here, this is the specs on the motor. The name is the type of propellant. This is a White Thunder, a Pro 29. That means it's a 29mm. It's a reload kit. This is the actual part number, and it says here, if you notice, this is a 1-grain casing. So you have a 3-grain engine casing. This is a 3-grain engine casing, and with that you've got two spacers. Here's the two spacers, and you got the casing retention ring. So your engines that you can shoot with this casing can be a 1-grain, 2-grain, or 3-grain. In this case, this is a 1-grain load, so you want the grain to be packed against a solid surface, so you would load basically two of the spacers inside, and so roughly the engine is about that long. So some information on this particular engine, and the way you read this, the first number is the total impulse. In other words, that's the total amount of propulsion that this engine has. In this case, it's a 57. The next letter, the letter is a classification of engines. Basically, it's a range of defined impulses. So a chart here, if you can read it, you're already familiar with the A and the B and the C engines, and you can see that as each letter goes up, the amount of total propulsion doubles. So in the case of when you were shooting the A's, you were shooting engines that could range anywhere from 1.26 to 2.5 Newton seconds. Converted to pounds per second, that is 0.28 to 0.56 pounds per second. You shot B's, you went up to C. C is in a range of any engine between the range of 5.0 to 10 Newton seconds, or 1.12 pounds to 2.25 pounds is a C engine. What you're dealing with here is an F. So you can see the F can range anywhere from 40 to 80 Newton seconds. So in the case of this engine, we have a total impulse of 57. So that puts it in the range of an F. So that's the reason for the F. So the letters are just kind of a gross way to categorize the different impulse range. The code and the requirements state that you are launching a model rocket, provided the model rocket weighs less than 1,500 grams with the engine loaded, and your total impulse does not exceed 160. So you can see on this chart, G is the highest engine you can shoot. You can shoot a lot of different ranges of G, anywhere from 80 to 160, but 160 is the max, which is 18 to 36 pounds. And as you can see, that's the largest motor rocket according to the TRA or the NAR. So to get into H and I, and you can see how much higher it goes, you have to have a level 1 certification, which I was able to achieve this summer. So now I can purchase and launch anything up to an I, and that's all the way up to a maximum of 640 Newton seconds, or up to 144 pounds per second. So what does all this mean? For a rocket to fly stable, aside from the aerodynamics, you need a lifting capacity of 5 to 1, what they call thrust to weight ratio. So it's recommended that you fly somewhere in the order of 5 times or more thrust compared to the weight of the fully loaded rocket. You can go down to a 3 to 1, but it's recommended, and I try to set up all my flights to be in the 5 to 1 ratio. So for the weight of this rocket fully loaded, we found from the simulator that you have to stay roughly in the 50 range. That's about the minimum, and the 50 range is right in the order of an F. So the range that you would fly this rocket is anywhere from F to the G. The simulation actually was run on this rocket with some lower Fs, because I was trying to get you a lower altitude, and I ran the simulation with like 40s, and you did not meet the thrust or weight ratio. They were like more like in the 3s to 4s. So with this, it gets you up to a maximum of 754 feet to be exact. So what this all means is you got this motor. It's a White Thunder powder. The White Thunder is a white burning propellant, and it tends to burn very fast. The next number is the average thrust. So in this case, the average thrust is a bigger number than the total. So if you take that number and divide it to this, that's the total amount of time the engine's burning. So because the average thrust is a bigger number, you can tell very quickly 59 goes into 57 less than 1 time. So you're really only burning about 0.9 seconds. Bigger engines will have a number here, and the average will be about a third. If it's a third, then you know you're going to dissipate that total power over 3 seconds. The dash number is the total amount in seconds of the delay charge. So if you don't alter the delay at all, the delay charge will not occur until 12 seconds after you lift off. So obviously this is something you need to adjust. So the simulators used mostly to see if the rocket will fly, and it can tell you at what point in time of the flight it's best to eject the parachute. And obviously the parachute takes a little bit of time to come out, so the simulator is smart enough to tell you, okay, before you reach the maximum altitude you should eject the chute at, you know, some point in the flight such that it's fully inflated at the max. So that's what we've done here. So as the casing shows, this is the 57F5912A White Thunder. You have a maximum preset delay of 12 seconds. The simulation has told us that for this rocket to fly its optimum, we need the charge to occur actually at 7 seconds. So you have to take out 5 seconds of delay charge. So we'll be using the tool, and I'll be demonstrating how to do that. But you can see on the tool it has different set points, and you can either subtract, you can subtract 3, 5, 7, and 9. So in this case we'll set it up where it's actually already set there. We'll put the little notch in -7, and we'll drill out the propellant. The other information on this sheet, I put here the actual, in other words, the numbers that are listed on the packaging are just kind of estimates, but this actual motor has 57.19 total impulse with an average thrust of 58.959, and as I told you, if you divide this number by that number, you get 0.97. That's the actual burn time. So this thing will burn through this propellant very quickly. According to the simulator, if all conditions match the simulator, you'll reach 754 feet. I'm sorry, scratch that. 754 grams is the total weight of the rocket with the engine in it. It will reach, a total altitude of 688. It'll achieve a maximum velocity of 148 miles per hour. It'll experience a maximum acceleration of 8.6 Gs. The time to reach the maximum apogee, in other words, the point where the rocket goes to 0 miles per hour and starts falling down its descent, is 6.73 seconds. Velocity at the time when the chute is deployed, the rocket will actually be traveling downward a little bit, and it will be running at about 27.6 miles per hour. So it already had reached 0, started falling. It'll eject roughly at apogee. By the time the chute is fully deployed, it'll be traveling about 27.6 miles per hour in a downward motion. It will actually be at an altitude of 664. So apogee's at 688. It'll be already come down to 664 by the time the parachute fully inflates. The total flight time from the time you push the button to the time it hits the ground is estimated 43 seconds. The time for it to clear the rod on your launch pad is 0.27 seconds. So that thing will lift off pretty quick. The velocity it will be traveling, assuming your rod is 6 feet long, would be 43.6 miles an hour. So just within that short period of time, that's how fast it'll be going. Your glide time, if you notice, the rocket engine actually burns 0.97 seconds. But then it's in an upward movement and basically gliding. You'll still see smoke coming out of the engine, but there will be no active burn. The rocket will glide for another 5.76 seconds, at which point it reaches its maximum altitude of 688 feet, and then it starts coming down. And during that time, somewhere in that travel time, it reached a maximum 148 miles an hour. Real quickly, the other engine that you got is a G. Now in this case, you notice it's a 108 G57 12-8. And if you look on the chart, a G engine can be anywhere from 80 to 160. So you can see the total propulsion here is 108, but the average thrust is only 57. So if you do the quick math, you can see the burn time is going to be about 2 seconds on this rocket. Again, the base delay is 12. This is like what they call a classic propellant. Basically, it's a cleaner burning, the classic kind of whitish gray flame. You'll have a little bit of smoke in this, but not a lot. According to the simulator, because this is at higher altitude, you will need to basically have a delay time set at 9. So 12 minus 9 equals 3. So in this case, you're going to set the tool up to -3 and drill out the delay cap. Again, actual numbers, total impulse is 108.095. The average is 56.008. The burn time, like we estimated, is around 2 seconds. It's 1.93 seconds. The rocket mass, because you're dealing with more propellant in this, brings the mass up to just over 800 grams. You should reach an altitude of about 1,658 feet. So you're doing almost 3 times the altitude, about 2.5 times the altitude of what the other one did on the G engine. You'll reach a maximum altitude of 246 miles per hour. The maximum acceleration at this time will get to be 10 Gs, just over 10 Gs. Time to apogee is 10 seconds. Velocity of the chute, again, we like to keep that, under 50 miles an hour. Here it's 20.8. The altitude at which the chute deploys is 1,644 feet. It will be coming in a downward motion. The total flight time is 96 seconds. So you're dealing with almost twice the time to fly here. Time to clear is 0.25 seconds from the launch pad. Velocity is 47.1. For the fins to take over and to guide a rocket, the rule of thumb is you want to be at least 30 miles an hour when you leave the launch rod. And that's why the bigger rockets have the longer launch rod, because once it exits, it's known that you're getting enough wind flow over the fins to guide the rocket. If you leave the pad slower than that, you can have what's called weather cocking, and it can tip to one side, and then when the motor engages, you could have a rocket go in a direction that you didn't account for. So that's another parameter that we look at. So both cases, this is really good. So your glide time here, although you're burning propellant for almost 2 seconds, you're still gliding a good 8 seconds. So it glides a lot longer to reach that higher altitude. So that's just some theory on the rocket engines and why it works the way it does. So just as a recap, when you look at the casing, this is the total impulse. The F is a range of impulse, and if you have a chart, you get an idea. You pretty well know that you're going to be running Fs and Gs for this rocket. This is your average thrust. So, dividing this number by this gives you an idea of the burn time, and then this comes standard with a 12-second delay. White Thunder, heavy thumping, burns very quick. Propellant, 29 millimeters in diameter, and it's a 1-grain casing. So it comes in the engine comes in a gray cardboard, got a date stamp. The engine's inside here. This is your igniter, so make sure you tear this off. Probably leave it in the plastic bag until you're actually ready to use it. So I'm going to use a pair of needle nose pliers, and I'm going to pull these two staplers out here, and I'm going to take this little cap off, and we'll pull the engine out and start doing the loading. Alright, so I got my videographer expert with me to help me out so I can free up my hands. So say hi, Tara.
Hello.
Okay. So like I said, just take these two of the staplers out with some needle nose pliers like this, like so, and you just pull the cap out, and you should be able to pull it out. So it comes in a plastic sealed package. So like I said, if you know you're going to shoot it at least within the next month, if you want to go ahead and prepare these, that's fine. But the point I want to make, they say that the engine propellant will oxidize. So once you cut this plastic, you kind of started the time where you need to launch these. So there's directions that come with each one of them. You can certainly read these to get more familiar. But in my case, I've read 1,000,000 times and I don't need to read it. So if you look at it between the casing, you can see it's a single grain. So if you lay it out, you're going to need the two spacers because the nozzle sticks out a little bit. So single grain, two spacers. So it comes with this yellow cap. You want to keep this. This protects the nozzle. This is the actual nozzle where the rocket flame comes out. And up here inside is the grain, and then the top is the injection delay, and we can take this out. Now these have O-rings. You want to make sure you don't gall these at all, but basically that's the delay charge. That gray stuff burns, and according to the package this is 12 seconds. So as soon as you light the rocket, this starts burning, and it takes 12 seconds to get to this point, and then this cap underneath this paper is black powder, and that basically explodes. It pressurizes the rocket, pushes the nose cone off, and ejects the parachute. You don't need to take all this apart, so I advise not to do that, but I'm just showing you all the different components. So you push that back on. Down at the bottom is the nozzle. It too has a O-ring, so be careful with that. If I shake this, I should be able to get the propellant out. Here's 1 grain of propellant. The top grain has a black cap that actually, that's the part that starts the burn, and that one's always in the top. If the grains should fall out, the tapered end of the grains go in facing upwards towards the charge. The 1 grain, if you got 3 grains, you would have 3 of these, but one of them's going to have that black piece. You want that one to go in first, like so, and you want all the other grains to go with the concave facing upwards. Once you push it in, you push the nozzle on, like so, and that is the engine. So now I'm going to show you, there's no reason why you should take these apart. That was just for explanation. The only piece you take off is the top piece with the white cap. That's your delay charge. As we said earlier, for this particular engine, you want a 7-second delay. So you set the tool up to -5, so you can see the keyway there, and we set it to 5. We pull it out, rotate it like so, and all it is a drill bit that basically, the more you turn it, the farther the bit goes down. So we're setting ours to 5. Because it's a 29, this is actually made for a 38. For 29, you need the little donut in there. You basically hold the grain, the delay grain side in, and you just start rotating it. I rotate the delay grain. I hold the tool stationary, and that's kind of push a little bit, turn, push a little bit, turn, push, 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 and then you feel it kind of bottom out. You feel that it's not going any deeper. So then you pull it out. You'll see some grain, so you tap that, get it out. You keep doing it a couple times until it turns pretty freely. You can tell you're not pulling any out. So I'm turning it. So it's good to have something to poke down there to pull it out, like so. You want to get all that out. Advise don't touch it too much if you can avoid it. You pull, it's kind of like a foam material. So just keep doing this until you're not really taking any more material. So it's bottomed out now. I'm just turning it. Keep turning, keep turning, keep turning. You're going to pull it out. See, and you see that's what it does. It leaves a hole like that. So you pull the bit out, kind of dump the extra out, pull it back on 5, put your donut there. I always do one more turn for safety's sake, and I feel now it's just turning and it's not taking any more material off. So that is set up for the delay you want. You've taken 5 out and it's set up for 7. So you basically push it back, clean any excess off, push it back. See the O-ring, push it until it, try not to crimp it until it snaps in place, okay? So now your engine is set up for a 7-second delay. You take your engine casing, the delay charge goes up towards the rounded edge. So first you put 1 spacer, rounded edge in first, 2nd spacer, rounded edge first. Now you push your engine in. You should always feel it bottom out and you still have the nozzle sticking out here. There we go. You have the retaining ring. I advise putting some white lithium grease on here a little bit so the threads don't gall. Basically you put it on, you rotate it, almost looks like a cigar tube. You keep turning and you feel it kind of bottom out, and then just turn it a little bit to make it snug. And if you want, you can put the little protective cap on it like that. Good. Alright, so now we take and you cut the igniter off from the side of the kit. And being careful not to cut the igniter, you open up the pack. So you've got the igniter. The igniter, basically, you can see the tip. That's the charge. Basically, it's 2 wires that come to a common point on the tip. You can undo this. Then you got 2 wires, conductive leads. This is where your alligator clips will hook onto. Always kind of undo them and spread them out a little bit. If you need, you might need some wire cutters to split it. See if I can do it with a pair of scissors. Yeah, so I split them out a little bit, give yourself some room. Okay. Some people advise keeping them together, that way you don't get a accidental discharge. So they say kind of twist them together until you're ready to hook them up to the alligator clips. So that's the igniter. You bring the rocket over. You see the bottom of the rocket there, Tara? So we take the bottom cap off, and then we put the engine in. We push it all the way up until it bottoms out. I advise taking the yellow cap off. Then you put the retention ring back on, let it bottom out, and kind of turn it just so it's snug. You don't have to wrench it down and make it tight. So the engine's in the rocket. So now you're getting, can you see this? We're getting the igniter, and we pinch it and you make it kind of straight, and you feed it up through the nozzle in the hole, and you keep going until it bottoms out. That's what you're trying to find, the bottom out point, because you want that black cap. So before you do that, take the protective cap and feed it from the outside hole through. There's a little hole in the side. Just let it kind of hang down. You put the igniter in to the engine until it bottoms out. Try it a couple times because sometimes it can get hung up, particularly on the multi-grain engines. Once you feel it bottom out, kind of pinch the igniter right at the base of the engine where it bottoms out and pull it back. So right there is where it bottoms out. What I do now is take and make a little loop like that. Okay? So I take it and put it back in. The loop is just outside the engine. And now I put the yellow cap over the loop and stick it on. So now you got the igniter coming out the side of the protective cap. You've got a loop of the igniter. That way it's not tugging inside the cap. And what I like to do is then I just kind of like bunch this up on the side like so. I get some blue tape. You use blue tape a lot at the launch pad. And so I just usually stick this on the side of the rocket like this until I'm ready. And if you want to be safe, the cap stays on during the launch. You can actually, if you want, you can put a piece of blue tape in there to hold everything secure. You don't have to, I rarely do, but if you want, there's no problem. That will definitely blow off. So when the rocket takes off, you'll go back to the launch pad and find this still attached to the alligator clips, and you'll see the it'll actually pop the little yellow cap off. You'll see that still attached to the igniter, but everything else will go with the rocket. So at that point, the rocket has the engine in it. It's ready to go. You've got the igniter leads tied together so there's no short. You can carry this around, whatever. Just be careful not pulling on the igniter leads because you want it to stay up at the top where the cap is. So the next step is load the parachute, and we'll be ready to launch it. So let's say the rocket is already launched. Of course, all this will be gone. At least when the rocket comes back, this is what you're going to have. When the rocket gets back, and provided it's cool to the touch, you just basically take the cap off. Sometimes it kind of sticks, the propellant kind of welds itself with the plastic casing. Basically put a piece needle nose pliers and you kind of grab the nozzle, not the casing but the nozzle, because you're going to throw that away. You basically pull it out like so. Comes out. Once it comes out, you grab it, put the rocket to the side. You'll unscrew this. Obviously, if you put the lithium grease on, it screws off pretty well. Again, you can use needle nose to pull this out. Because this hasn't burned, it should come out pretty good. Sometimes you have to put something on the other end to push it out, which is fine. So you push out, you pull it out, you basically throw all this away. When it comes back, you'll see this paper has come off and the black powder charge will be gone. There's nothing in here. There's no sense in taking this apart. All this is disposable. So now you're left with a ring, the engine casing, and what I recommend is take a small can of WD-40 with the little nozzle. And what I do is I spray all in there. I take the spacers out first though. So you take both spacers out, you spray it good, spray it good. You then take like a brush, bottle brush, you just put it in, go a couple times this direction, a couple times this direction. You do the same with the spacer, spray it with WD-40, go through those. I do that between each launch. It does two things. It gets the excess propellant out, so that make these go in a lot easier next time. And also you're slowly lubricating this, so each time it's easier to put in. And I think we talked earlier, but when you get this case for the first time, there's a label on the outside. Take that off, spray some WD-40, take some Scotch-Brite, kind of polish that out, because it is a tight fit and you don't need anything on the external. If for some reason something happens and you've already adjusted the engine and you don't end up shooting it, by cutting the plastic at one end, you can put this back in the plastic. I recommend folding it over, get some clear packing tape, tape this up really good, put it back in the case. You can actually put the end cap in. I would write on here that you've already adjusted the ejection charge, and you can actually store it like this. I've stored it for a couple of months and had no problems. You know, obviously you want to wrap the igniter back up, put it back into plastic, and here's the tape. You can tape it back. So this is the retention ring to the rocket. I've never really had to clean these, but you can spray WD-40. Always put that back on so you don't lose it. So at this point, either now reloading the engine load with another engine, put in the rocket, reload the parachutes, and you're ready to go. That's